Hi, today we're going over section 6.2, which is multiplying and dividing rational expressions. So for these, multiplying and dividing rules that apply for rationals formed by integers are the same as for rational expressions. So when we multiply the numerators together, and then we multiply the denominators together. When we divide, we leave the first fraction alone, and then we flip the numerator and denominator in the second fraction. At that point, we then multiply the two fractions together using our rule from here of multiplying the numerators together and then the denominators together. So for example, simplify and state restrictions if needed. So we have 2/3 times 5/8. So we'd multiply across our numerators. So 2 times 5 is 10 over 3 times 8, which is 24. We'd then reduce this to lower terms. If we wanted, we could reduce to lower terms at this point as well, because we could see that the 2 would partially cancel out the 8, and then we would get the same fraction. This one here, we have a non-permissible, so we'll take care of that first. So we have x cannot equal 0. And then multiplying them, we have x squared times 6, so that's 6x squared over 3x. Simplifying that, 6 divided by 3 is 2, x squared divided by x is x. So this is the reason why we state non-permissibles first, because in this case, we no longer have a denominator once we simplify, but we still have that non-permissible from where we started. Okay, sometimes factoring before multiplying will make things easier. So this one, I have 2x plus 2 over 5x minus 5 times 3x minus 3 over 4x plus 4. So in all of these, I can factor something out. So 2x plus 2, I can factor 2 out. For 5x minus 5, I can factor a 5 out. The 3x minus 3, I can factor a x minus 1, or sorry, 3 out, giving me x minus 1. And this one I can factor a 4 out, giving me x plus 1. So we'll do our non-permissibles at this point. So x cannot equal positive 1 or negative 1. And then if we have a binomial in a numerator and one in a denominator, they can cancel out. So x minus 1 cancels out with x minus 1. X plus 1 cancels out with x plus 1. So that's going to give us 2 times 3 is 6 over 5 times 4, which is 20. Reduce that to lower terms, and we get 3 over 10. Okay, next example, simplify and state restrictions if needed. So we'll fully factor each of these, and then we'll state restrictions, and then cancel out any binomials that we can. So if this first one, when factoring it, we're looking for two things that multiply to 12, add to 7. So that'd be positive 3 and positive 4. Factoring the denominator, we are looking for two things that add to 4, multiply to 4. So that'd be x plus 2 and x plus 2. And then that's going to be multiplied by, we're looking for two numbers that multiply to negative 6, add to negative 1. So that'd be negative 3 and positive 2. And down here, we have a difference of squares. So we know that's x minus 3 times x plus 3. So we'll do our non-permissibles. So we'll cancel. So we've got negative 2, positive 3, negative 3. We'll then go through and cancel out terms. If we cancel, x plus 2 cancels out with an x plus 2, x plus 3 cancels with an x plus 3, x minus 3, and x minus 3. So that leaves us with x plus 4 over x plus 2. And this is as simplified as we can get this one. Now, since dividing makes a second fraction flip, we'll take non-permissible values from both the numerator and denominator of the second fraction, the one that's flipping. So for example, simplify and state restrictions if needed. So looking at this one, look at the numerator and denominator, x cannot equal 0, y cannot equal 0. So next step would be to flip those. So we got times 12y over 5x squared. At this point, I would then start canceling some things out. So this y will partially cancel this out. This x cubed will cancel out x squared, leaving an x up here. We can also partially cancel the 3 and the 12. So that cancels out, leaving this with a 4. So that's going to give us 64x over 5y. Next one we have is x squared minus 4 over x plus 3 divided by 2x minus 4 over x squared plus 2x minus 3. Okay, so this one, I'll probably flip it, then we will factor it. So we've got x squared minus 4 over x plus 3 times x squared plus 2x minus 3 divided by 2x minus 4. We'll go through and factor what I can now. So this is a difference of squares. So that's x plus 2 times x minus 2 divided by x plus 3 times, and then factoring this, we're looking for two things that multiply to -3, add to +2. So that's x plus 3 and x minus 1 over, we can factor 2 out of here. So that's 2 times x minus 2. So we'll do non-permissibles now. So from here, x cannot equal -3. Then we have to look at numerator and denominator of this one. So that'd be 1 and 2. We can then go through and cancel like terms. So x minus 2 cancels out with x minus 2. X plus 3 cancels out with x plus 3. So our simplified form is x plus 2 times x minus 1 divided by 2. Now we won't FOIL this out, we'll leave it in factored form. So practice for this section is on page 535.